So your calculator can tell you how to get the least squares regression line. Like you can put the data in your L1 and your L2, and it'll do that calculation for you. It is unlikely that you are going to have to do it that way. Okay, more than likely they're going to give you what's called a regression output when you're going to use that. Now, but there are some ways, like, so essentially the big idea is if I have this data set, and let's just pretend we didn't have a calculator that was capable, okay? The very first thing you would find was that value R, that correlation. And the way you would find it is taking the average of ZX times ZY for each point. And so what I mean by that, you guys remember for that hot second, we kind of talked about R, and we said like, oh, this point is really strongly negative. This one's negative, but not quite as negative. With the calculator says after I have R, I can find the slope by doing that R times the standard deviation of Y over the standard deviation of X. That formula is on your formula sheet. The line of that least squares line, the line of best fit, goes through X bar, Y bar. So if I were to draw in that line of best fit for this scatter plot, if this was my X bar, Y bar, the line would go through that point. That was not a good sketch of X bar, Y bar, but the line goes through that point, okay? And then the y-intercept it is unlikely that you will use these formulas, but on those big formula sheets, guys, they are kind of up here. Cool. Okay. So what am I going to expect you guys to do with this least squares line? One, you got to be able to find it. I'm going to ask you to interpret R and R squared. How many of you guys are feeling pretty good at understanding R and R squared? You feel good? Okay. I'm going to ask you to explain a value called S. So we're going to talk about S real quick. Okay? All right, when we have our regression line, this is a residual, this is a residual, those residuals, all those distances from the lines, we got those, yeah? Could I make a dot plot of just the residuals? Give or take. What would we expect of that dot plot? Where should it be centered? Like, are you guys with me? That this point, this point, this point, this point, everything below the line has a negative residual, and everything above the line has a positive residual, right? So the mean of our residuals is 0. Is everybody with me? And typically, those residuals, like a dot plot of the residuals, hopefully is normal. We'll talk about that a whole lot more way later on in the course, okay? But the residuals, you're going to have some positive, some negative, yeah? Now, S is a very specific statistical measurement that is the standard deviation of those residuals. So, are you guys with me? That if the residuals are the distance between the point and the line, yeah? The distance between my prediction and what would actually happen. Is everybody comfortable with that? Does that make sense? Okay. That means, well, the standard deviation is the average those errors are from 0, because it's distance from the mean. 0 being a residual of 0, meaning the prediction matches the actual value. So, if I have a point that's off by, say, that much, couldn't we call this distance the prediction error? So the standard deviation of the residuals, S, is the average error in prediction. Okay? So I'm going to be doing the same. I'm going to ask you guys to interpret a few things. Okay. Slope, y-intercept, r squared, and s. Those are the 5 interpretations you need to be familiar with. Okay. Now, I'm not going to worry right now about you guys putting this data into your calculator. Okay? Maybe I should. You know what? I'm actually going to worry about you guys putting this data into your calculator. So I will go back. How are we doing? Another minute or? Skylar, did you figure out where?
No, I'll figure it out.
Okay. So, real quick, why don't we, since we're in here, I'm going to show you guys. Your calculator can do the scatter plot for you. Like, you can get a vibe to look at the scatter plot rather than doing it by hand. To do so, you just hit second and y equals to bring up all those statistical graphs that we've been dealing with. And instead of, like right now we have the histogram in there. If I hit enter, it'll do the scatter plot. I can move over so that I'm selecting the one that looks like a scatter plot. And if I hit zoom 9, you'll be able to see the same scatter plot that we've been dealing with. Yours might look slightly different scale-wise.
Did you hit distribution?
No, I hit second y equals to bring up the stat plot.
Okay. Oh.
And then choosing the one that looks like a...
Did you set the window?
If you hit zoom and then 9, it'll automatically fit the window.
Mine just doesn't look like yours.
Well, your window is also rectangular versus mine is a little bit more square. And
That's true. Is there supposed to be one that's engaged?
yeah,
Second one.
got it.
Figure it out.
Okay, so now let's do the scatter plot.
Thank you.
Everybody good? What do you
Should
get?
we get to that? Then what do you go with?
So if I hit graph right now, you won't be able to see it.
Mhm.
There you go. That's how we get the scatter plot. So here's how we find the line of fit. Okay? You're going to hit stat. We want to do a calculation. We want to calculate that line of fit. So you're going to go over to calc. And this time we're going to choose option number 8, where it's like linear regression a plus bx. Everybody good? And it's going to say, hey, what do you have in L1? Or where is your x list? Well, that we put into Y1, and the y list we put into L2. Everybody good? The frequency list.
Mine has it as L3, and then I tried something.
You have to hit second 2.
Oh,
Cool. Everybody good? And I'm just going to go ahead and hit enter. And it gives me all this information. Now, do any of you not have all this information? It wouldn't be surprising if some of you guys don't have the r and the r squared. Okay. To fix that, you go to mode. Go all the way, it's like really far down on the bottom. And you see where it says stat diagnostics? You want to have on highlighted for the stat diagnostics. If we get to the test and you feel like you need this and it's not there, that is the kind of thing that you can just bring it to me and I'll help you with it on the test. Okay? All right. And now once you turn on those stat diagnostics, you should be just fine. Okay? All right. So, cool. So what does this look like? So if I asked you what is this equation, you would say, if we were in Algebra 1, we would say y equals 255.56 plus or minus 10.53 x. Now, can you guys tell me what's wrong with me writing my equation that way?
Oh, you don't have a hat.
We need to have a hat. Okay? And we need to define the variables. So where x is equal to pace and y equals heart rate. Or from the get-go, you could just write this in context. Now, the most likely way that you guys are going to be finding the line of fit is not going to be in your calculator, okay? That's how you do it if you need to. But more than likely, what you're going to be given is one of these computer regression outputs that has all this funky stuff in it, okay? You guys, are you with me? That slope is the number in front of the x. What's the math word for a number in front? Coefficient. Do you guys know this word? Okay. So if I'm trying to figure out what is my slope, I want to find the coefficient of my x variable. Do you guys see what I'm saying? So the way we use this table is we're going to end up using the coefficients. What do we call a number that doesn't have a variable in math? A constant. So the coefficient of the constant, or my constant in general, is equal to this one. So this coefficients column is how we get our equation. And this is saying the coefficient means number in front, so this number goes in front of that term. Do you guys see what I'm saying there? Okay, so if I give you one of these, the way you find your equation is here. So now all we have left to do is use this and do some interpretations. Okay, you guys, what is my slope in this case then? Negative 10.53 is my slope. Are you guys cool if I call that negative 10.53 over 1? Okay, so what does that mean in context? Well, our context here is pace and heart rate, right? Okay, so what do we know in general about slope? What is the slope? Change in y over change in x. What would that be in this setting? The change in heart rate over change in pace. And we can use this to figure out our interpretation. So which number goes with the change in heart rate? The negative 10.53, and the change in pace is 1. Okay, so we're going to say for every 1 minute increase, technically minute per mile increase in pace, notice how I didn't say for every 1 minute per mile. I'm describing the change in is if it goes up by 1 minute per mile. Okay. Meister's heart rate decreases by an average, underlining an average, of 10.53 beats per minute. Does that seem like a reasonable interpretation? Talk to me about a y-intercept. What does that mean? It's where the graph crosses the y-axis. More importantly, in order to be crossing the y-axis, the x-coordinate has to equal 0. So like your y-intercept is going to be the point 0, then whatever your y-intercept is. So how would I interpret that? What does that really mean? X stood for minutes per mile, right? And Y stood for heart rate. If Meister takes 0 minutes to run a mile, her heart rate would be 255.6 beats per minute. Hey guys, am I allowed to predict for 0 minutes per mile? Here's the deal. Y-intercepts rarely make sense. Okay, because most of the variables that we're dealing with, having the x-coordinate be 0 would be kind of weird. Okay. Now, at this point, you guys said you're feeling pretty good about r and r squared, yes? Then I'm going to skip over those, mostly because I want, 1, they're interpreted earlier in the packet, and 2, I want you guys to have some time to work on the next homework because you guys have a quiz on Wednesday. And then S. So we would say on average, the error in predicting heart rate is 5.46 beats per minute. Notice that R squared, do you guys see how it's all there? Okay. If you're given just one of these boxes, again, you're not going to, we will eventually worry about those other numbers in the box. We're not going to worry about it right now, okay? Did I give you R?
No, well, it's essentially, it's just square root of that.
It's not just the square root. What do we know about r, guys? It was negative here. Do you guys get what I'm saying there? Do you guys remember the picture of the graph? It's negative. Okay, so like, to find r, well, we knew that r squared was 85.6%. You're never, ever going to use the adjusted r squared, so don't even worry about it, okay? So what you're going to do is take that r squared as a decimal, take the square root of it, and what you get is r is equal to plus or minus 0.925. But r, there's really only one r, right? So how do I know that this one would be a negative 0.925 if I just had this, right? Our calculator told us it was negative. How do I know that it's negative? But if all I have is this, how do I know that this is a negative relationship?
Because the pace is negative.
Not the pace, the coefficient of the pace. The slope of the line is negative. So the sign of the slope is how you decide is r positive versus r is negative. The line's going up, it's positive, and the line's going down, it's negative. Questions?